The Measure of All Things, a report on the science, history and culture of measurement. Part 1, The Foundations of Measure, Episode 1, The First Ruler. The human-centric origin of measurement. The act of measurement is a fundamental human endeavor, an instinct as old as civilization itself. The earliest recorded systems of weights and measures originate in the 3rd or 4th millennium BC, born from the practical necessities of agriculture, construction and trade. In the dawn of civilization, long before the invention of abstract scientific principles, humanity sought to bring order to the physical world. Lacking external tools, it turned to the one instrument that was universally available and constant to every individual, the human body itself. This was the first reference frame, the original ruler by which the world was sized. Early Babylonian and Egyptian records, as well as the Hebrew Bible, indicate that length was first measured with the forearm, the hand, or the finger. These were not arbitrary choices. They were intuitive, portable, and universally understood within a community. The cubit, one of the most ancient and widespread units, was based on the length of the forearm from the elbow to the tip of the extended middle finger. For smaller gradations, people used the palm, the width of the hand, the digit, the breadth of a finger, or the span, the distance between the tip of the thumb and the little finger of an outstretched hand. Longer distances were paced out, giving rise to units like the foot and the pace. This reliance on the human form was a global phenomenon arising independently in cultures from Egypt and Mesopotamia to ancient Greece and Rome. It reveals a foundational principle of metrology. Measurement is the act of relating the unknown to the known. In the beginning, the most known and constant thing was the human body. This practice established a core theme that persists throughout the entire history of measurement, a continuous search for ever more stable and universal reference frames, a journey that begins with the individual's own body and progresses to the societal, the terrestrial, and ultimately, the cosmic. The problem of inconsistency and the dawn of standardization. While body-based units were convenient, they carried an inherent and critical flaw: variability. Whose foot should be the standard? Whose arm defined the cubit? This inconsistency was a significant impediment to large-scale trade and construction, creating endless opportunities for dispute and fraud. The solution to this chaos was the first great leap in the history of metrology: standardization, an act not of science alone, but of authority. The first step toward standardization was to designate a single official source, typically the ruler of the land, as the ultimate reference. The Egyptian royal cubit, dating to around 3000 BC, was not just any forearm. It was the length of the pharaoh's forearm plus the width of his hand. This abstract concept was given physical form in a master standard, a rod of durable black granite against which all other measuring sticks were to be compared. The importance of this standard to the functioning of the Egyptian state cannot be overstated. It was essential for the precise construction of monuments like the Great Pyramid of Giza, for surveying and re-establishing property lines after the annual flooding of the Nile, and for the systematic collection of taxes. The Egyptians enforced this standard with the ultimate penalty. Historical records indicate that builders were required to calibrate their wooden cubit sticks against the granite master at every full moon. Failure to do so was punishable by death. This stark anecdote reveals that from its very inception, standardization was an instrument of power and social order. This pattern of royal decree repeated throughout history. In medieval England, a land of chaotic and overlapping measurement systems inherited from Roman, Anglo-Saxon and Norman French traditions, kings sought to impose order. King Henry I, who ruled in the 12th century, is said to have decreed that the yard should be the distance from the tip of his nose to the end of his outstretched thumb. In 1324, King Edward II declared that the inch was the length of 3 grains of barley, laid end to end. These acts were attempts to create a single, authoritative standard to facilitate commerce and assert royal control. Controlling the standard of measure is a fundamental way a central authority imposes order, enables a large-scale economy, and asserts its legitimacy. This theme, the deep connection between measurement, law and power, would echo centuries later in the grievances of the French people on the eve of their revolution, who saw the profusion of arbitrary, lord-specific units as a tool of feudal oppression, measuring volume and mass with nature's units. While length could be standardized against the body of a king or a master artifact, the measurement of volume and mass required different solutions drawn from the natural world. Before the widespread use of weighing, the capacity of containers like gourds or clay pots was compared by filling them with plant seeds, which were then laboriously counted to determine the volume. This method, while tedious, provided a consistent if imprecise way to ensure fair trade in commodities like grain. When the technology of the balance scale was invented, these same natural items became the first standards of mass. Seeds and stones, valued for their relative uniformity, served as the original counterweights. The carat, a unit of mass still fundamental to the gem trade today, has its direct origin in the carob seed, which was prized in the ancient world for its remarkably consistent weight. Similarly, the grain, which became the smallest unit of mass in the apothecary, Troy and avoirdupois systems, was originally based on the weight of a single grain of wheat or barley, and was used for weighing precious metals. This early approach to measurement reveals a worldview fundamentally different from our own. The units were highly domain-specific and disconnected from one another. A cubit used for construction had no defined relationship to a volume of grain measured by seed count, which in turn had no logical connection to a carat of gemstone weighed with carob seeds. This reflects a pre-scientific understanding of the world, where different physical properties were not yet seen as interconnected by universal laws. This disconnected world of early measurement is a crucial starting point in the grand narrative of metrology. It sets the stage for one of the most profound intellectual achievements in the history of science, the creation of a coherent system where all units are elegantly and logically derived from a small set of fundamental standards. The journey from a world of disparate ad hoc measures to a single interconnected system is a central story of human progress.